students face while studying the topic of optics at GCSE and A levels and up until the first year of physics degree. So I'd like to differentiate and just talk about the things that we start off from when reading the chapter of optics. So the first thing we need to differentiate between is lenses and mirrors. Lenses are they are not opaque at all. They are completely 100% transparent and to some extent, in some cases, translucent, and they are designed to transmit light. They have two kinds: convex and concave. Convex are the ones that are known as convex or converging lenses, and they are denoted a positive according to the Cartesian coordinate system. Because they focus light behind the lens, hence they're deemed positive. And so concave or diverging lenses, they summate and focus the light in front of the lens, hence they're known as negative, because according to Cartesian coordinates on the graphical representation of optical depiction, if the light falls and is merged into a single focal point behind the lens, the lens is deemed positive. And if the lens is able to divert and diverge and scatter the light, enabling it to get focused on a focal point in front of the lens, it's known as diverging. So, and then we've got the lenses, and then we've got the mirrors. Pupils need to realize and appreciate the difference or differentiate between lenses and mirrors. Lenses are a tool to transmit, focus, and converge or diverge light for different varying purposes, whereas mirrors are specific tools to reflect light. Now, this is where it becomes confusing. Mirrors can either be plane, i.e. parallel formation, or convex, like convex lens, or and then concave, like a concave lens. Now, they are the mirrors that are convex shaped are positive and convergent, and the mirrors that are concaved in their formation or topography are negative and divergent, i.e. they scatter light. So the third aspect is the slabs. So we use quite a lot of slabs. Two types of slabs are used, triangular and rectangular. Rectangular slabs are used for refraction experiments, whereas triangular ones are used for Newtonian dispersion or scattering experimental observations and demonstrations of these concepts, i.e. Herschel critter or Newtonian dispersion, or and then the rectangular one is for refraction, i.e. Snell's law. So Snell's law is for refraction and reflection, but it's only for plane mirrors. It breaks down at convex and concave because further mathematics required to reinforce the formulaic design of predicting where the light would get reflected if it bounces off of a concave or a convex mirror. So this is what we need to realize when talking about lenses, mirrors, and slabs. And lenses can be convex, convergent, and positive, and concave, divergent, and negative. Similarly, mirrors can be concave, convex, and plane. So this is how things are. Please try to understand. This is quite the crux of your understanding of physics, optics, when it comes to the chapter of optics. So lenses, slabs, and mirrors. Prism, triangular prism, and rectangular prism for Newtonian dispersion, Herschel and critter experiment, and refraction experiments. Plane mirrors So the Snell's law is consistent for plane mirrors, um, for reflection and refraction, whereas it breaks down when it comes to convex mirrors and concave mirrors. I hope this helps. I hope you've learned something today. Thank you very much. Cheers.